thing would be passed through. The whole point of the Chainlink framework is to generate multiple Oracle networks. So this is where you get to level 4. And Chainlink has been at level 4 for many years. Basically the ability to generate multiple separate networks dedicated to performing their specific function. So the way that you could view Chainlink networks is like services, decentralized services. There are many Chainlink Oracle networks that are on production securing value as decentralized services for transmitting data after validating it and making it reliable and immune to certain types of manipulation. And that is really where Chainlink started, is how do you create multiple individual Oracle networks for validating data. Now Chainlink has moved on to not only validating market data and proof of reserves and identity and various other types of data, but also using those Oracle networks to do computations and now cross-chain. So Chainlink fundamentally is not about making a single network or a single chain. There is no Chainlink chain. It is about making multiple separate decentralized services so that you can have the security of each service segregated to that Oracle network, and so that you can scale that Oracle network to the maximum degree possible as you want to scale that service. And Chainlink has been at this level for many years now, and in the Chainlink network there have been well over 1,000 Oracle networks launched into production securing real value. If you count the testnet networks, the staging networks, all the other networks that didn't secure value, it's in the thousands. At the 5th level, which only Chainlink resides at this level from the point of view of making secure systems, and really only on an Oracle network basis, only Chainlink really resides at the 4th level, you have the ability to both make multiple networks and the ability to manage risk. So the ability to manage risk depends on detecting various risky events, categorizing them as risky, and then enabling the system to adapt to remove those risks. For example, on the data side, the Chainlink network was successfully able to adapt to the risk of FTX as a price data source. So FTX was a data source that was heavily used by many different data providers. The Chainlink network system detected that that was a problem, and then it removed the data providers that were heavily weighted towards FTX, therefore eliminating that risk of that centralized exchange affecting the decentralized data generated for DeFi. And that's why during that crisis, the Chainlink Oracle networks continued to provide accurate prices. So this is a pattern that we've consistently built into Chainlink and know a lot about, and the Chainlink network and community is very familiar with. It's not only how do you make multiple networks to solve a security problem, but how do you then manage the risk of the new problems that appear dynamically as they appear. So CCIP and Chainlink currently is at this 5th level. And if you look at CCIP, you'll actually see that it's made up of multiple networks. So we've even gone further than generating a single network for a service. Every CCIP bridge is made up of multiple networks. It's made up of networks that execute the actual transaction, and then it's made up of a completely separate network called the risk management network that's written in a different stack, in a different way, and it has a completely different goal of validating whether those transactions should happen. So approving or disapproving those transactions without ever signing for them or ever touching the tokens in any way. So you have kind of in CCIP an even further level of decentralization where it isn't even a single network powering every single bridge, which is a segregated, scalable, separate service. But you have one network or a set of networks that are responsible for the transactional throughputs of the network, for actually executing the transactions in the executing DON and the committing DON. And then you have the risk management network, which monitors the transactions for various risks. And you can actually put various other additional risks that you want to monitor in the risk management network. So if you're transferring value, if you're putting in data that's going to trigger and control value, there's a reason that the Chainlink system has processed over $8.5 trillion in transaction value, why it's been live on production for so many years without significant issues. It's because the system not only can make separate services that are secure and decentralized, but it's also because the system can adapt to manage these various risks. And this is the same level of security and risk management that we've now injected into CCIP. And this is why many of the top protocols in public chain DeFi are using it actively and switching to it from other systems that are either made up of basically 2 nodes, so they're back at level 2, or they're at level 3, where you only have one network which fundamentally can't scale and which aggregates all the risk for all the bridges in one place that's more likely to get attacked and manipulated. So basically, what we're seeing now is that both the security of CCIP and the risk management of CCIP is valuable and useful to both public chain DeFi and private bank chains, which also see the large value in this security. And the organizations we're working with there are very security sensitive because many of them settle amounts of value in the quadrillions. And they have very serious security requirements and review processes. And when they look at the security that we've been able to create through this decentralization, through this ability to segregate bridges into separate services, through risk management as a separate capability in its own separate network, I think what they see is the level of security that is kind of at the very limit of the type of security you could create. And so they're seriously looking and in many cases now becoming willing to put large amounts of value into that system because of that security and decentralization. So the fundamental question for me actually has always been, how much security do we really get from decentralization? And I found that if you can separate out each separate Oracle network, you can scale the security of each Oracle network separately, and then you can add other Oracle networks to bolster that security. For example, we have proof of reserve Oracle networks that can be conditions for the risk management network. And so eventually you can have a multitude of networks managing large amounts of value by doing each of their respective risk management roles and making sure that the transactional value flowing over the system is both properly secured and managed against risk. And this is very important because if our industry is going to grow, we really need to get to the level that the systems in our industry can properly move and secure and prove things, not about billions of dollars, not about hundreds of billions of dollars, but eventually about tens and hundreds of trillions of dollars. And that's what we're building Chainlink to be able to achieve.